All right, I'm back. Here's 82. So if I'm going to take I'm not even worried about e to the x. So if I'm going to take the integration of this, the hook, the derivative of 2x is 2. So to undo that hook, I need 1/2, and 2 is not part of the answer. So 1/2 is part of the answer. The antiderivative here, if I do this, if I integrate this, the integration of this is just f at x. That's equal to the integration on the other side. So that's why integrating this is just capital F at that. Then plug in 3. 2 times 3 is 6. Subtract, plug in 1. 2 times 1 is 2. And you got your answer. Population y grows according to this equation, where k is a constant and t is measured. If the population doubles every 10 years, then the value of k is what? So to recognize that for 84, when I integrate it, it's this population growth model of x that grows. And then it tells you that when you divide by c, it doubles. So it means 2 when it doubles. And then every 10 years. And then solve for k with your calculator. So if you solve that, just go solve, comma k. You get the answer A. '86. The base of a solid is a region the first bounded by this and the line x plus 2y equals 8. All right. If cross sections of the solid perpendicular are semicircles, what's the volume? So semicircles, we're going to integrate from 0 to 8. It's pi r squared divided by 2. So it's pi r squared divided by 2, but the radius, you have to go top subtract bottom. So the top is, that's right, this is y equals. So we can't write it this way. So I'm going to subtract x and then divide everything by 2. So it's going to be 8 minus x divided by 2. And then I need to divide that by 2, because that right there is the diameter. So this top subtract bottom is the diameter. Divide by 2, that's the radius. This is what you would type in your calculator. So type this in your calculator, and then the answer should be, press pause and try it, it should be C. Let f at x be an antiderivative of this. So f at 1 equals 0. So then what does f at 9 equal? So the starting value is 0, and then I'm going to integrate from 1 to 9, the derivative just type it in, and you would get your answer. And it goes from 1 to 9. And if you type it in and put in the answer is C. I was going to do it by hand, but it's a calculator question. So why? The hook is 1 over x, so it's just ln x to the 4th. Let's type it in. Number 90, we're so there. The base B of a triangle is increasing at a rate of 3 inches per minute. Its height is decreasing. So the base is increasing, the height is decreasing. Which of the following must be true about the area of the triangle? So the formula is half the base times the height. So the first times the derivative of the second plus the second times the derivative of the first. So if I plug in -3 and +3, so if I plug in -3, I get -3/2 base plus, if I plug in +3 here, I get +3/2. So when is the rate positive when looking at this? So when is this greater than 0? Or is the other way? It must be true. So A is decreasing when the base is smaller than the height. So if the base is smaller than the height, this negative will be stronger than this positive. So the answer is D. So when B is bigger, it's decreasing because of this, the negative. It's not always increased, not always decreasing. It's not constant. So it's either C or D. And so when B is bigger, it's going to be negative, not the other way around. Last one. K is between 0 and pi/2. This is the curve. So the area from 0 to K of cosine x so K is here, and under the curve, and x equals K. So we're actually going to go K to pi/2. This is what we know. So from K to pi/2, so from x equals K to pi/2, the area is 0.1. This area is 0.1. Then what must K equal? So I'm going to integrate this from K to pi/2. And then I'm going to solve it. So I'm going to plug in pi/2 minus plug in K and make it equal to 0.1. And then you're going to use your calculator, go comma K and solve it. And the answer is D. Tell me if I'm right. Mr. G Math over and out. I am proud of you for finishing all of it. You're amazing. I'll see you soon after the break. Till next time.